Hi everybody, welcome to Tech Tip Friday. I'm your host Kurt Staley, that plastics guy, and I'm bringing you a tech tip that you could take to the shop floor or the engineering department today. So I've done some recent content about biopolymers, and that would be Soluble out of Finland, and I've also done content on EcoRect, a product made in India that I'm handling in Canada. So I wanted to talk a little bit about the differences between, well, water soluble and a biopolymer. Now, water soluble, obviously if you put it in water, it will dissolve. That's the whole point of the product. Be it for something like an institutional laundry bag. You have dirty clothes, you put it in an industrial washing machine. During the course of the cycle, the bag just disappears. It's less handling, and you're not dealing with cloth and whatnot that has to be recycled. Cloth garbage bag or laundry bags, or even a conventional polyethylene laundry bag that would have to be recycled. But the water-soluble product will also break down in any marine environment, makes sense, and in a landfill. So great, makes sense. A biodegradable polymer will break down in an industrial composter, as will the water-soluble product. It will break down in landfill, as will the water-soluble product. The main difference is the biopolymer will not break down when it gets wet. So think of an application like the organic food waste containers that most of us have under our sinks. If you used water-soluble resin for that, that would just cause the bag to disintegrate, and that's not going to be much help to anybody. So you want a compostable bag. So that product can be put into municipal, compostable recycling. The bag will break down, and the contents, the organic waste, can be turned into good, product for your garden and soil and other things as it gets composted, which is exactly what you want. So the biopolymer will have more structure to it, if you will. It will act like a conventional plastic, but it will break down. The water-soluble product will start to break down the moment it gets in contact with water, as it's intended. So make sure when you're looking at a biopolymer, you know the difference between the two. Or ask a guy like me, even dressed in green today, to talk about these materials. We can help you navigate a biopolymer, a water-soluble product, and where you want to use the two, and we have an arsenal of product to offer you, and we're pretty excited about that. Film conversion, injection molding, extrusion, thermoforming, we can now offer it. We're excited. We want to talk about these things. We think this is the future of where plastics are going for many of the convenience items. I don't think we're going to see biopolymers for a while yet in automotive, certainly not water soluble. That is not the intended market segment. You don't want them in anything that needs to be durable long term. Water soluble, it's a phenomenal product for bags, packaging, institutional applications, as I mentioned, with laundry. So there you go. There's a quick one for you on the differences between a biopolymer, water soluble, where you'd want to use them. I'll talk more about this because I think it's a point that really needs to be hammered home. And as we transition to more and more of these materials, it's going to become more and more relevant. So there's your tech tip. Have an awesome Friday, a great weekend, and we will talk to you again next week. Thanks. Bye for now.